Welcome to the Gresty Academy 5 must-know college entrance exam questions on polar rose graphs. So let's first of all have a look at the 6 golden rules for how to draw these and how to identify them. Okay, number 1, rose curves in polar coordinates have the form r equals a cos n theta or r equals a sine n theta, where a is the maximum value of r and that's the length of the petal, and n determines the angular frequency. That's rule number 1. Rule number 2, if we got r equals a cos n theta, the first petal peak occurs at theta equals 0 on the positive x-axis, and for r equals a sine n theta, it occurs at pi over 2n, and that's how we can see if it's a sine or a cos curve. For number 3, for odd n, there are n petals, and for even n, there are 2n petals. So another way we can identify what the curve is. Number 4, for odd n, the domain 0 to pi maps the entire curve and then retraces the same petals for pi to 2 pi. But for even n, we need the entire domain 0 to 2 pi to map the whole curve. The 5th rule, for odd n, the petals are distributed with spacing 2 pi over n. For even n, they're distributed with spacing of pi over n because there's twice as many of them. And number 6, r passes through O every pi over n and it changes sign. And this is really helpful for us to be able to identify the direction that a curve is taking. During the interval where r is less than 0, i.e. every other time that it passes 0, points are plotted on the opposite ray, theta plus pi. Okay, so let's have a look in practice how that applies to 5 college entrance exam questions. Here's question number 1. First of all, what is the polar equation of this rose graph and what domain of theta fully describes it? Okay, by rule 2, as the first petal peak is not on the x-axis, we know it's sine, and we can see that the maximum value it reaches is 3, so we know, therefore, that it's going to be 3 sine something. And how many petals are there? Well, if we count, there are 12 petals, which is even. So by rule 3, we know that it's 3 sine 6 theta. Because it's even, there are twice as many petals as that n there. Now, by rule 4, because this is even, we need the domain theta going all the way from 0 to 2 pi to fully plot this curve. That's question number 1. Okay. Question number 2. Let's have a look at question number 2. What's the polar equation of this rose graph? Okay. From rule 2, as the petal peak here is on the positive x-axis, we know it's cos, and we can clearly see that the maximum value is 2. As there are 7 petals, which is odd, by rule 3, we can therefore describe this curve as r equals 2 cos 7 theta, and by rule 4, as this is odd, we only need theta going from 0 to pi in order to fully plot this curve, and between pi and 2 pi it just replots exactly the same petals. Okay, question number 3, getting a bit harder now. Indicate the direction in which r equals 2 sine 2 theta is plotted as theta increases. Okay, well, just to check, let's have a look, make sure this is r equals 2 sine 2 theta. We can see that the maximum is 2, and we can see there are 4 petals, and therefore by rule 4, we need 2 pi to map the whole curve, and by rule 5, the petals are spaced pi over 2 apart, but everything is correct there. Okay, let's have a look how we look at the direction. Well, clearly it starts here when theta equals 0. And then what happens? Okay, so basically as theta goes from 0 to pi over 4, it maps this bit here. So that bit there is number 1. And then what happens? From theta is pi over 4 to pi over 2, it maps this bit here. So that bit is number 2, and that's from pi over 4 to pi over 2. Now r has hit 0, and so therefore we know that r is now going to be negative. So basically, instead of being in this quadrant here, which is where we should be if we're going around here, as r is negative, we move to this quadrant here. So the third one to be drawn is this one. That is the third one, and that is pi over 2 to 3 pi over 4, and then the fourth one is this. Again, r is still negative here, so this is the fourth one here, which is 3 pi over 4 to pi. Now just that these r was greater than 0, and in this one r was less than 0. Okay, so now we're at pi, and now as r has gone back to 0, r flips to being positive, so now it goes back into the correct quadrant, if you like. So this one here is 5, so that's the 5th one there, and that one is pi to 5 pi over 4, and then the 6th one is here, going back there, that's the 6th one, and r is greater than 0 here, and this one here is 5 pi over 4 to 3 pi over 2, and finally r hits 0 again, so it goes negative again. So instead of being in this quadrant, it goes into this quadrant, so r will be negative here, and the 7th one is this one here. That's the 7th one, going like that, and that one there is for 3 pi over 2 to 7 pi over 4, and then finally the 8th one, which has finally mapped the entire thing, that one is 7 pi over 4 to 2 pi, and finally that's the 8th one there, and finally we've mapped the whole thing, and you can see it has taken us 2 pi to do that. Okay, question number 4. Question number 4. Okay, so let's just have a look again. 3 cos 3 theta. Well, we can see that the peak is 3. We can see that the petal peak is on the x-axis, therefore it's cos. And as there are an odd number of petals, 3, we can also see that it's 3 cos 3 theta. So let's have a look. Now, we know that this time it starts here at theta is equal to 0. So this one here is the first one, and we go in that direction there, and that's from 0 to pi over 6. And then, because we pass 0, r goes negative, and so instead of going along this part of the quadrant here, we go to the opposite part, which is here. So in actual fact, it goes like this, because r is now negative. So this is part 2, and that's from pi over 6 to pi over 3, because r is negative. And then we come back along here, that's 3, and that is from pi over 3 to pi over 2, and again r is negative here, and r is positive in this top bit. Okay, and now where are we going? So now basically we got to pi over 2, so now we cross 0 again, so r now comes positive, so it's correctly in its right quadrant again now. So this here is the 5th one, that there was 1, 2, 3, so this one here is the 4th one, and that one goes from pi over 2 to 2 pi over 3. The 5th one is this one here, which goes from 2 pi over 3 to 5 pi over 6. And here, r is greater than 0. And then again, r goes past 0, so it flips to negative. And that means that we go into this one here, which is the final one. That's the 6th one. There is the 6th one. And this part, r is less than 0. And that bit there is 5 pi over 6 to pi. So you can see we've drawn the entire thing and we've only needed pi because it's odd. Let's just have a quick look. Pi to 7 pi over 6. What happens there? Well, as r is less than 0 for pi to 7 pi over 6, all it does is it just draws the same bit as 0 to pi over 6, i.e. it just redraws that bit. And then 7 pi over 6 to 4 pi over 3, again, this time as r is greater than 0, it just retraces pi over 6 to pi over 3. And so basically you can see that this thing just completely retraces between pi and 2 pi. So it only takes pi to actually trace out the entire curve. That's question number 4. Finally, we have question number 5. Sketch the portion of this rose graph r equals 2 sine 5 theta for theta going from 0 to pi over 2 only. Okay, so basically what we need to do here, we know it's sine because it doesn't have a peak on the x-axis there, and we know it's 5 theta is odd because there's an odd number of petals, and we know that the maximum is 2. So therefore we know that we start here at theta equals 0. That's easy. So we come up to this bit here. Now that bit here is 0 to pi over 10. Here is pi over 10. So that is the first bit. The second bit is obviously coming back here. And r is greater than 0 here. And that bit there is pi over 10 to pi over 5. And then what happens is because r hits 0, it flips to be negative. So instead of going up here, it goes to this opposite bit here. So the next bit is this. That is the third bit here. So that's the 1 bit, that's the 2 bit. This is the third bit. This one is from pi over 5 to 3 pi over 10. And off here, r is less than 0. And this next bit, 4, is 3 pi over 10 to 2 pi over 5. And we've got to be a little bit careful because we're only asked to draw until pi over 2. Okay, now r flips positive again. And so basically, it goes back into where it should be. So this bit here is the 5th bit. Going up there, that's the 5th bit. And that is from 2 pi over 5 to pi over 2, and that is the bit that we want. So the 2.5 petals that we have drawn is r equals 2 sine 5 theta from 0 to pi over 2. Okay, well, I hope you found this useful. If you have, please subscribe to the Gresty Academy YouTube channel and like this video by pressing the little thumbs up button. Okay, thank you.